I see there's a lot of confusion on how the event loop works in JavaScript and how JavaScript can run asynchronous code if JavaScript is a synchronous language. So I will easily explain you how it works, you will understand it, and you will never forget about it. It is very simple how it works. You just need to understand it. So let me simply first begin with giving you a simple explanation of how the call stack actually works. This is the requirement for understanding on how the event loop and how JavaScript runs asynchronous code. So when you run a simple example like the one shown in the screen, the function 1 will get called, it will print out function 1 to the screen, function 2 then will get called, then function 2 will get printed into the screen, and then function 3 will get called, and function 3 will get printed into the screen. That's very simple. And what happens with the call stack is also very simple. Function 1 gets called, it gets pushed into the call stack once it finishes execution, and in this example, it prints function 1, it gets removed from the call stack. Then the second function will get called, it will get pushed into the call stack, and then it will finish execution, it will get removed, and the same with function number 3. So this is very simple. Second example is also very simple. Let's imagine this example where we call function 1. Function 1 will call function 2. Function 2 will call function 3. Function 3 will print function 3. Then it returns to function 2. It will print function 2. Then it will return to function 1 and it will print function 1. Very simple. And how does it work in this diagram? Function 1 will get called, it will get pushed into the call stack, and since function 1 requires function 2, it will get pushed into the call stack. Function 2 will need function 3, it will get pushed into the call stack. Then function 3 finishes execution, will get removed. Function 2 finishes, it will get removed. Function 1 finishes and it will get removed. So very simple. Now let's see this example with a set timeout function in the second function. So what will happen is the first function will get executed. It will print first function into the screen. Then the second function will get executed. And since it's a timeout function, then it will wait 5 seconds and the whole system will not wait until second function actually finishes. It will go to third function, it will print third function, and then once the 5 seconds are passed, then the callback function will get executed and it will print callback function. So, but how does it really work? So let me show you in this diagram below how it actually works. Function 1 in the above example gets called, it prints out function 1, it gets removed from the call stack. Then function 2 is called, and function 2 calls actually a set timeout function which belongs to Web API. And it is Web API that actually handles asynchronous code. It is not the JavaScript language. JavaScript is synchronous, but the Web API provides interfaces and APIs, so functions that can be asynchronous. So what happens here is that function 2 has a call to set timeout. It gets removed from the call stack and gets pushed into Web API. Web API will take care of it. And a set timeout is set to wait 5 seconds and then call the callback function within the second function. Let me put it here so that it's visible, but it's managed by the Web API. Now, since the call stack is empty, it goes into the next function and calls function number 3. Function number 3 gets executed, it prints out function 3 and gets removed. After 5 seconds have passed, Web API will push it into the callback queue. And the event loop is always checking both the microtask queue, I will explain that later, the callback queue, and the call stack. It detects that it has a function in the callback queue and that the call stack is empty. This is necessarily, if that happens, the callback, the event loop, removes it from the callback queue and puts it back into the call stack. Then it executes the callback function, and once this finishes, it gets removed from the call stack. So this is how it works. Very important here, it's the web API that manages asynchronous code. And the key here is that when there's a function that calls any web API function that is asynchronous, it gets removed from the call stack. So, and if it gets removed, then another function can get into the call stack and get executed synchronously. So this is key. What happens with the microtask queue? So set timeout is actually a callback function. Fetch API, the fetch, for example, is actually a promise function. And what happens with a promise function is very similar. This, imagine a function number 3 that has a promise function inside. Then it will get pushed into the web API. The web API will take care of the fetch asynchronous function, and once it finishes, it will get pushed into the microtask queue. So instead of getting pushed into the callback queue, it will get pushed into the microtask queue. And the event loop is checking, as I said before, the microtask queue and the callback queue. If there is a function in the callback queue and in the microtask queue and the call stack is empty, it will give priority to the microtask queue. It will execute the function here, it will get removed, and then it will go, the event loop will go and check the callback queue and will put it back here, and it will execute everything what is necessarily in the callback function, and it will get removed. And I will prove it to you. If we go to Visual Studio Code, we have this function with the set timeout function. If we call it like that, we'll see that what happens is, as we know, first function will get printed, third function will get printed, it will wait for 5 seconds, and then the callback function will get printed into the screen. If I have set some breakup points here to pause the execution of the program, if we run on the back, and I will show you the call stack. If we run on the back, we launch the program, the first function has been run, and it is waiting to print the first function. This is the call stack, and as you can see, the first function is in the call stack. If I now continue the execution, this will get removed, and then the second function will get into the call stack. You see, the second function is in the call stack. Now it will call the web API set timeout function, and this will get removed from the call stack. And now we entered the third function. The third function is in the call stack back again. And if I continue the execution, then again, the second function goes into the call stack and it will execute this callback function. Once it finishes execution, the callback function, it will remove both the second function and the callback, the callback function from the call stack, as you can see. And that's how it works. So I hope this clarifies how it works. The most important thing is to understand that JavaScript is a synchronous language, and it's the web API that manages actually a synchronous language. And with the microtask queue and with the callback queue and the event loop, it enables web API to put back the results of the functions like the set timeout or the fetch functions into the appropriate queues and put it back to the call stack so that synchronously it can finish executing what's in the call stack. So I hope this clarifies. If you have any questions, leave it in the comments. If you like the video, like it. If you like more content like this, please subscribe. It will help me and it will help grow the channel. Thank you very much.